Hello, and welcome to another presentation in the LADAL Opening Webinar Series 2021. My name is Mark Schweinberger, and together with Michael Hoare, I'm co-directing LADAL, the Language Technology and Data Analysis Laboratory at the School of Languages and Cultures at the University of Queensland in Australia. Before we start, I'd like to read out an acknowledgement of country, which we do here in Australia to express respect and gratitude towards the Indigenous people of Australia. So I'd like to say that we as members of the University of Queensland acknowledge the traditional owners and their custodianship of the land from which we are broadcasting this webinar. We also pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to country. I'd also like to say that we recognize their valuable contributions to Australian as well as global society. Now, if you want to know more about LADAL and the resources we provide, please feel free to explore the LADAL website. The URL of the LADAL website is shown on the screen. You can also find information about past and upcoming presentations in the LADAL Opening Webinar Series 2021 on the events subpage of the LADAL page. If you want to keep up with what's going on at LADAL, you can follow us on Twitter, and you can also check out past presentations on our YouTube channel. If you have any questions, suggestions, feedback, please do not hesitate to reach out to us by email. Now, without further ado, it's my honest, real pleasure to introduce today's speaker, Laura Janda. Laura Janda is a very dear colleague of mine. We've worked together in Tromsø. She's absolutely fantastic. She's an absolute star. And to tell everyone else a little bit about Laura, so during the Cold War era, Laura combined the studies of Slavic linguistics at Princeton and UCLA with US government-funded adventures as an exchange student behind the Iron Curtain in countries that have since changed their names, USSR, Czechoslovakia, and Yugoslavia. After over 2 decades at the University of Rochester and UNC Chapel Hill, she moved to the University of Tromsø in 2008. Regarding her background, Laura was an early adopter of cognitive linguistics in the 1980s. Wow! And she's explored quantitative methods since 2007. Her research focuses primarily on the morphology of Slavic languages with various admixtures, such as North Sami, conlangs, and political discourse. So, Laura, it's a real pleasure to have you here. You're wonderful, and I'm very looking forward to your talk. Please let me stop sharing my screen, and you're invited to share yours.
Okay, so here we go. Yes, so thank you very much to Martin for that really generous introduction, and thanks to everybody who's here today. And this talk has 2 parts. I'm going to start with the part about trolling. That's about a repository that everybody can use, and then I'm going to go over to the part that's more about what we can do concerning languages with rich morphology and how to both understand how they work and how also to help people to learn them. So yeah, so here is a little maybe a little advertisement for a repository we made here at Tromsø a few years ago. Maybe it's even very appropriate that I call this a place for us, since Steven Spielberg is coming out with a new version of West Side Story this year. Anyhow, so this is where you can find it, and I can also show it to you live if you want. So we call it Trolling, the Tromsø Repository of Language and Linguistics. And the basic idea here is that this is a place where you can put up the data and code that goes with your published works, or even with unpublished works. And then you can have those two things point at each other, and it will be easy for you to find, easy for other people to find, and it'll be professionally managed. Sorry. Okay. So it's an international archive of linguistic data and statistical code. Everybody can use it. It's built on the Dataverse platform, which was developed by Harvard University, and it complies with various international standards, including CLARIN, It also assigns a permanent URL to each post, a DOI, and there's metadata that can be harvested and used in order to make everything searchable. And really important here is that when I went to our colleagues at the University Library in Tromsø, I said, you know, nothing like this exists in the world. We really need something like this. They actually got excited about it and took it on. So it was kind of one of those nice situations where I could say, here's an idea, and I could help to design the idea, but then hand it over to somebody else to take care of it afterwards. So, but it's professionally managed, and I think that's actually really important. And it's spun out now. So now this university library also has created similar sort of resources for several other types of research groups, not linguistics. So this is what it looks like, and I can also go live if anybody wants to see it live. This is just like the front page, and there's also a getting started with trolling. If you saw here, that's a link where you can find various things like a video. I can also show you. There's a funny video that I and one of my graduate students star in. If you have time, we have time, and you want to see it, let me know. There's also a user guide. There's lots of information about it. But basically, what we tried to do is, one of the people on our Hans Boas, maybe somebody you know, on our board, he said, you know, you need to make the instructions clear enough so that your grandmother could use it. So that was basically our idea. So the basic steps in trolling, you create an account only if you're archiving something. You actually don't even need any account to search or download data. You can do all of that without any account. It might take a day or two for your account to be approved because this is professionally curated. But if you're going to upload your things, then you need to create a study. You need to enter various kinds of metadata so that it will be searchable. And you need to upload your files in persistent formats. And that basically means like things like TXT, PDF, and such. And then when you're going to be searching for a study, you're going to need to agree to trolling terms of use. After you've uploaded your study, you need to submit it for approval and receive an acknowledgement. And this actually takes a little bit of time, and because it is professionally curated, even when I send in studies, it's not uncommon that my colleagues over in the library say, well, but actually you should add this. I mean, and obviously you should have things like README files and such. You can always edit your study later if you need it and resubmit it. And all of the previous versions of your study are archived, but only the latest version will show up in initial searches, although other versions can be found. I mean, personally, I think this is useful even to keep your own things in order to make sure that you will always be able to find your own work. It's very handy. So in searching for a study, all of the cataloging information, which is the metadata, can be searched, including the author, the affiliation, country, nation, the date of production. There's keywords. For us, language is particularly important there, and topic classification. And there's an advanced search that makes it possible to, combine these filters in whatever way you want, pretty much. The terms of use is that you affirm that you will not use the materials that you downloaded to identify individuals or organizations. You will not download or use materials that would be prohibited by law, and that you will cite the data as stipulated in the data citation information in any publications or reports that you make using the data. I think what I'm going to do here is I'm going to just show it to you live just for a second or two. And if anybody has any questions, you can ask about them. Here it is. So this is what it looks like, and you can search for a study. So let's take, here's something. For example, I'll just take this one. For example, so here's something that Hannah Eckhoff has written, and here we have We have a full description of it. Usually what you put in here is the abstract from your publication, if you have a publication. And here you have, keywords, and here's the information about the related publication. So the publication has the URL for the trolling post, and the trolling post has the URL for the publication. And here then you have all of the files that you can download and see, and you see what kinds of files there are. She has a README text here. I actually recommend, when you're doing this, that you put a number at the front of every single file so that you can make sure that they're in a logical order that makes sense. So start with like 01 README, for example. But yeah, so and here's more about the metadata and everything. So that's basically what this looks like. It's free and open, everybody can use it. So are there any questions about trolling, or should I go back to the rest of the talk here?
No, I think it's fine.
Okay.
I think it's open source and people can check it out, right?
Yeah. Okay. So then I go to the rest of my rest of this talk. So I'm going to be talking about strategic targeting of rich inflectional morphology for linguistic analysis and L2 acquisition, since I teach a language with such morphology. So we're going to look at what are the challenges of this kind of rich inflectional morphology. And also I'm going to show that this follows a Zipfian distribution. There's also something that's called a paradigm cell filling problem, about trying to understand how speakers of languages actually use these languages with huge paradigms. We're going to work on a database model of rich morphology. I'm going to show you the results of a machine learning experiment, and then I'm going to show you a tool that we actually created based on these research results in order to help people to learn such a language. Okay, and I didn't do this alone. So there was a fairly big team here, and I'm not going to name everybody here. We also received financing from a Norwegian agency that's changed its name twice during the project, and every time the name of it becomes more difficult to more of a mouthful. So I'm not going to go through that, but it's here. And this is also a collaborative work with the Higher School of Economics, which is basically Harvard of Moscow. And so I have these two colleagues who are also from Moscow. So I should go back a little bit. As Martin said in the introduction, I've been working in cognitive linguistics for a really long time. I've also been teaching for a really long time. And I used to believe that it was a really great idea to get students to memorize paradigms by, I started teaching on a chalkboard, writing out the paradigms on the chalkboard, and having the students having the students recite the paradigms and being able to produce full paradigms of all of the words that they learned. But now I believe that full paradigms are probably a fiction, and I'm going to get into that a little bit more, and that we can really strategically target the acquisition of morphology in a way that makes a lot more sense, and we can have like a more cognitively realistic model of what it means to speak and learn a language with rich morphology. Most languages in the world have a rich inflectional morphology. The language I'm speaking now is kind of this weird exception, really. And such morphology can involve huge numbers of forms. And also we should remember that it can be really complex. It's not just about glomming on, like sort of like extra Lego pieces onto words, that it can involve also prosodic differences and morphophonemic alternations, and that it can be amazingly complex. And of course, language nerds like me, I think that's just super gorgeous and beautiful, but maybe not all of my students are so thrilled about it. Here's a little sample from Europe. If we say that a language has high inflectional morphology, if it has like more than 4 forms for both nouns and verbs, then we could say that we have all of these languages in Europe that have high inflectional, rich inflectional morphology. Mid would be if it has a fairly large paradigm for maybe just verbs or just nouns. In most of these cases, it's just the verbs. And low is when we're fairly impoverished in both of those measures. But this is just to give us sort of an idea that really, when we're talking about most languages, I mean, this is something that really involves most languages, even though a lot of people speak this particular language. Here's an example from one of my favorite languages, Kolik rzeczy znasz, tolikrát si člověkem. This is a Czech proverb, and this Czech proverb contains only 6 words. But in these 6 words, we have all of these grammatical categories that are marked by morphology. And in a language like Czech with rich inflectional morphology, even a small basic vocabulary of a few thousand words can entail hundreds of thousands of paradigm forms. How does this work? And here's a visualization of that too. So if we have just 5,000, so this is if we're taking 5,400, 5,500 words that are inflected. This includes, this is actually from Russian, and we'll see this picture again. I'll explain it again in a little bit. But so this is if we have both nouns and adjectives and verbs. So as you see, like this number goes up really, it's not very high because this is just the number of words, but this is the number of paradigm forms associated with that same number of words. So these are the full paradigms. And you see that like this is a really small vocabulary, just 5,000 odd words, and still we're pushing up towards 250,000 paradigm forms. Yeah. And so I'm kind of interested in what's really going on between these 2 lines in languages. Yeah, a little bit more about the complexity of inflectional morphology. It's often considered to be both essential to L2 acquisition, but also to be a bottleneck, to be actually more difficult than both syntax and semantics. And as I mentioned before, the morphophonemic alternations can complicate the picture. So it's not just a matter of adding desinences to stems. We can have consonant and vowel alternations. We can have fleeting vowels, which we call years in Slavic languages, and we can have these super segmental alternations of like stress and length and tone and such. Here's an example from North Sami. So here is the basic paradigm of the word goipni, which means partner. And it has in its base paradigm with just case and number, it has 13 cells, but 10 unique forms because there is some syncretism. But you can see that things are going on here. So we have like a consonant cluster that changes. We also have a vowel that changes. We also have a diphthong that changes, or triphthong that changes here. So we have quite a bit that goes on, but this is just the basic paradigm. If you add on to this the fact that every single noun can also have a possessive suffix on it that marks both person and number, then we have 130 paradigm cells, and we have 91 unique forms. And you can see that also funky things happen. So for example, when we go to the locative singular, so this locative singular form, this form here suddenly becomes an ST. So there's an awful lot that's going on here, yeah. But do the speakers of North Sami actually need or use all of these forms? And how does that work? That's what we're going to be looking at. And what I want to show you is that there is a Zipfian distribution of paradigm forms. everybody's familiar with Zipf-ian distributions of words, but this works also for paradigm forms. And here we have some examples of Zipf-ian distributions for noun forms for 5 different languages with different size paradigms. So we are going from the impoverished paradigm of just singular and plural up through Estonian, which has a nice busy paradigm with lots of case and number. And you might complain that these are really small corpora that I'm looking at here. The reason I'm using these corpora is because in order to get a realistic assessment of what's going on, I needed to use gold standard corpora. In other words, corpora that have been tagged manually. And so this is, and so because otherwise I wouldn't be able to pick up the fact that if the forms are syncretic, whether or not they are the same or different forms. And as you see here, as the paradigm size increases, the percentage of lexemes that are tested in with a full paradigm decreases. And I have bold-faced Russian here. It's sort of in the middle. But so you see that, for example, in this 1 million, this is a syntagmus corpus, which has been manually corrected. In 1 million tokens with a paradigm size is 12, so 6 cases and 2 numbers. We have almost 22,000 nouns that are represented there, but only 13 of those nouns are found in all 12 forms, and that represents less than 1/10 of 1% of these 22,000 almost nouns. And because Zipf's law scales up, these numbers aren't going to change substantially no matter how big your corpus is. And we can use as a sort of a proxy, obviously it's not perfect, but the idea of a large language exposure as being kind of like a big corpus. So there have been various estimates for how many million words per year a native speaker is exposed to, and it's it's approximately between 5 to 10 million words per year. And if these Zipf-ian distributions remain the same, even for very large corpora, this means that a native speaker of Russian encounters all 12 paradigm forms of less than 0.1% of the nouns that they are exposed to in a lifetime. And because the noun paradigm is the smallest paradigm, the adjective paradigm is bigger and the verb paradigm is even bigger, then the portion of adjectives and verbs that are attested in all paradigm forms is virtually 0. So yeah, so what does this mean for words? At the word level, this means that each lemma has a unique grammatical profile, which is the frequency distribution of its paradigm forms. And I'll show you what I mean by this with some concrete examples. So here are the full paradigms of 5 high frequency words. And it's important to keep in mind that these are high frequency words because they're going to have more filled out paradigms than most words. So here's the word for fear, for example, in all of its forms. Yeah, and same for soldier and department. But if we look at that syntagmus corpus in which all of these words are attested more than 50 times, here's what we see is that there are only like maybe 1, 2, or 3 of these forms that are attested more than 20% of the times that the word is attested. And then there may be a couple more forms here and there in plain that are tested over 10% of the time. Gray are the ones that occur kind of, fairly rarely, and the blanks are the ones that are not attested at all in this corpus. These are well-behaved words these are the ones that I could show you with like almost a maximal attestation, yeah. But there are lots of other very high frequency words. So these are all similar frequency words that are attested much less. So here's another group of 5 words. And here you see that, for example, I think it was attested like 69 times, this word expanse it's only attested in one form in 1 million words. And this word background is also mostly attested only in one form. This word frame also and even this word problem, you can find it in singular. In fact, all of the singular forms are attested, but notice that it's much happier, well, except for this one, but it's much happier to exist in the plural, apparently. And similar thing with champion. There's only 2 forms that are used a lot. So we see we have some concrete examples there. And these kinds of observations, of course, have been around for a while. I'm not the first one to make it. Farrell Ackerman and others have dubbed this what they call the paradigm self-filling problem, is that native speakers of languages with complex inflectional morphology will routinely recognize and produce forms that they've never encountered, even without being aware of the fact that they've never encountered these forms. So the question is, like, how do they do this? Yeah. And I can give you an example. So here's a Russian gerund, недокармливая, which means while under feeding. It's a gerund of the verb недокармливать, which itself is a low frequency item. And this gerund has no attestations in over 360 million words, which would be roughly equivalent to a lifetime exposure. But all native speakers of Russian can be expected to, instantly and effortlessly understand, and also just as effortlessly produce these forms in appropriate contexts. And you can find this form a couple times if you go out on Google. So, so the question is, how do they do this? And how does this work? And what I'm going to propose here is a data-based model of rich morphology, or usage-based model of rich morphology, which instead of having like a table of equiprobable cells, and by equiprobable cells, I mean something like this, yeah? Instead of assuming something like this, what we assume is a multidimensional space that's partially populated in many different ways by many different lexemes. And that inflectional morphology can be mastered through exposure to these partially overlapping subsets of paradigms. And this produces a cognitively plausible model that explains why native speakers have the intuition that full paradigms exist. Because actually, if you go and tell a native speaker that full paradigms don't exist, they might fight with you about that. But the evidence is that they probably don't exist. And what they're doing is they're triangulating from these overlapping sets. So here I'm going to set up like a little, like a little animation, if you will, of what this might look like. So this actually is a real space done by correspondence analysis of the paradigm cells for Russian masculine animate nouns. So here we looked at 95 Russian masculine animate nouns, and the distribution of their forms, and the correspondence analysis gives you this as the space. And you can see some of them are kind of on top of each other, but this is like a 2-dimensional space. It's actually a much higher dimensional space, but we're crunching this down to 2 dimensions to make it easier for us to look at. But so let's imagine that now we take a sample of nouns. We randomly grab various nouns that we're learning as we're learning Russian. And so we learn one noun that appears quite a lot in the nominative and dative and locative, and a little bit in the genitive, and also in the plural of the nominative. Yeah. And then, so then we've got that one. We have another noun that really likes the genitive, accusative, and instrumental case. We come to another noun that really likes the plural nominative and plural dative and genitive cases. We get another noun that really likes these oblique cases, but not so much these other cases. We come to another noun that's used a lot in the nominative and the locative plural, and maybe a little bit in some of these other ones. We have another one that's used only in plural, but only in the oblique cases, not in the nominative case. We have another one that's used almost exclusively just in the nominative singular, for example. And then maybe we have another one that really likes the dative case, for example. And what I'm trying to suggest here is that, as you add in more and more nouns, this space becomes entirely populated, and then it's possible to kind of like move around within this space and also make reasonable guesses around what's in this space. And here's what that space actually looks like with real nouns. So here are those 95 high frequency masculine animate nouns. And you see that there are some that are really way out on the edges, yeah? And there are also some that are really sitting in the middle, and there are some, they populate various parts of this space. But together they populate the whole space, but nobody does it alone, and everybody does it in their own way. Everybody's in a slightly different space. So any single lexeme gives exposure to just a subset of the paradigm, and each lexeme has its own signature, if you will, its own subset of its most typical forms. And collectively, they populate this whole space of case number combinations. But we have these specific things. So this is an analyst. So here is the word analyst. And this one is often found in the nominative plural in sentences like an analyst make the point that analytiker mit child. And this is the word champion that we saw a little bit before, and it's very much attracted to this instrumental singular. That's why it's way out on the edge here, because it's used a lot in this expression to become or be the champion. There you need the instrumental case. So what we see is that typical word forms are motivated by constructions, and I'm going to tell you a little bit more about that towards the end too. So, and again, if anybody wants to make a comment, you're welcome to jump in at any time. So to move on a little bit, now I'm going to tell you about the machine learning experiment that we did on this type of data. So again, we're going back to that 1 million token plus gold standard Syntagrus corpus. And we made an ordered list of the most frequent forms for the three main categories of inflected words. So verbs, nouns, verbs, and adjectives. And then what we did was we did an iterative experiment of machine learning with training and testing. So basically we took the 100 most frequent forms of any noun, verb, or adjectives, yeah, for specific ones. And we trained on that. And then given that, the task was then to take 100 new words that you haven't learned and say, and now you have to predict a given form for each of those words and predict what those were. And then what we did was that was the first iteration. In the next iteration, all of both the training and testing data becomes the training data, so the 200 most frequent forms, and then the task is to predict the next 100, so the ones from 201 to 300, yeah? And then again, all of that becomes the training data, and then you predict the next 100, and et cetera, until we basically run out of data. So testing is always predict paradigm forms for 100 previously unseen words. I'm going to show you a little bit more specifically what this looks like. And there were two versions of this experiment. So there was one version in which the algorithm was trained on the entire paradigm, so it learned all of the forms. It was like that really good student that I wanted early in my career that memorized the whole dang paradigm. And then there was another version where it learned only the lemma and the single most frequent form for that lemma. So it learned one form. And then we compared how well they did for the testing. So here's a little bit what this looks like in terms of like the actual data. So this is the most frequent form for any noun, verb, or adjective. It's actually a verb form, and it's the third person singular present tense verb form for the verb to be able. And so and so on and so on. So here are all of these. So you have the form and its frequency, but the frequency isn't part of the training data. Actually, you have the lemma, and you have the part of speech, and you have the parse of the thing. And so on training, you would get all of this. And if you were training for the whole paradigm, then you would also get the entire, all of this information for the entire paradigm of that verb, yeah? But if you're testing, then you were told only, okay, the lemma is watch, and it's a verb, and here's the parse. I want you to give me the form. And I want that maybe you don't notice, but there are also, this included also things that were irregular. This is an irregular verb. This is also a suppletive noun, for example, because this plural form is suppletive. So it included all of these things. Yeah, and then what the testing data was then to take a new word that you've never heard of before, and then you had to given what part of speech it was and what the parse was for that form, you had to then predict what that form actually was if you're this machine model. So I hope that's all clear. So now I'm going to go back. This is a picture you saw before. So this also compares the amount of data that these two models were learning. So this is the model that's just clunking along, learning one form for every single word it learned. Yeah, so it's only learning 5,400, 5,500 forms and then being tested on that. And then this is the model that was like my really good student that learned every single form for every single word, and it learned, over 200,000 forms. So, and you might think that the model that gets the most input should be the most successful because it knows the most. It's the smartest model. However, it looks like that's actually not the case in that it gets overwhelmed. And so here is a graph of the outcomes here. So remember that for the testing, the task was always to predict 100 forms for previously unseen words. And so the x-axis here is the same as it was before. This is like the number of words, yeah, and we're doing this in chunks of 100. And then our accuracy, this is both the number of forms and the percentage because it was 100. And we see that at the beginning, everything's terrible. And then for a short while, for about like the first 1,000 words or so, actually my SMART model was smarter. It did do somewhat better, but everybody's doing badly. We're still predicting, 40% or less correct forms, yeah? Then we have a little time here where they're kind of neck and neck. And then after that, this model takes over permanently. After it's learned 1,800 words, the model that has learned just the single most frequent form is better at predicting forms for new verbs and adjectives and nouns every single time. This blew my mind. I thought it was really weird, but it's a fact. What we think is happening here is that excess data is probably overpopulating the search domain. It's just like, we just were talking about traveling. It's like, trying to crush too much in. And if this is overpopulating the search domain for the computer, imagine what it's doing to the human beings, the students. We also looked at errors. So this is only when an error is made. And here we're measuring the errors in terms of average Levenshtein distance. So what was the average Levenshtein distance? So Levenshtein distance is how many letters you have to change in order to go from the wrong form to the correct form. And so then we averaged that for each trial. And here you see that aside from there was one, this was one kind of like odd situation, but after 11 iterations, this model also, when it made a mistake, it goofed worse. Its mistakes were not so egregious. So that was also pretty amazing too. So to summarize from the machine learning experiment, it seems that learning is potentially enhanced by focus only on the most typical word forms that are attested for each lexeme. And that actually accuracy increases and severity of errors decreases, and that this finding is consistent with a usage-based and cognitively plausible model. So then the next question is, what do we do with this? How do we escape from our overstuffed paradigms? I think that textbook writers have always focused on certain forms and constructions sort of like by instinct, but now we can do this in a way that's actually scientific and consistent. And what we've done is we've created something that we call the SMARTool, the Strategic Mastery of Russian tool. I'm going to show this to you live in a minute. It's a free web resource for second language learners of Russian that implements our findings, and this is also partially, this is the same funding thing that I talked about earlier. So this was inspired by our research as cognitively plausible. It's a strategic focus on the highest frequency word forms. It reduces the task of learning a basic vocabulary of about 3,000 lexemes by over 90%. This is something that we can continuously update and also custom tailor. I'm going to show you an example of that too. And we've done this whole thing, as you probably already saw, it's on GitHub, and this has been specifically designed with an architecture that's as lean and non-specific to Russian as possible, so that anybody who is working on any other language can use this architecture and build a SMARTool for other languages. Just a little bit about our vocabulary selection. We collected vocabulary from 5 major textbooks of Russian, and also from something that's called Lexiический minimum, the lexical minimum. This is what is used in Russian as a foreign language instruction in Russia. And this kind of just shows according to various, this is the European standard, this is the US standard, and this is the Russian standard. So we took items from all of these sources, and we selected. It's more than these numbers, slightly more for various reasons I don't need to go into. But so we have approximately 500 at each of A1 and A2, and 1,000 at each of B1 and B2. So it's approximately, but it's over 3,000 lexemes, and it can be extended very simply. And what we did was we illustrate all of the typical context, because it's not just the form, it's also why each of those forms is used. So as I showed you before, there are specific forms for words that are used most often, but that's because they are used in typical grammatical constructions and lexical collocations. And what we did was we also provided corpus-inspired example sentences. I mean, in a sense, these were corpus sentences, but we kind of like removed some of the clutter that you often find in real corpus examples, so that they would be usable by learners. And I'm also going to show you the Russian constructicon, but I want you to think for a minute. Yeah, here's what this looks like. I want you to think for a minute what this means. So we have 3,000 words, yeah. And each of these we're showing the 3 most common word forms. Occasionally it's fewer if there's a word that is used over 90% of the time in only one form, then or one or two forms, then we show those 1 or 2. But it's basically 3. So now we've got 3,000 times 3. We've got 9,000 forms, yeah. And every one of those 9,000 forms, we needed to go into the corpus, and we needed to study up on what were the typical grammatical constructions and lexical collocations that motivate every single one of those forms. This was a big job. And I was able to hire some rather brilliant linguistic students in Moscow to help out with this, thank goodness. But I'll show you live what this looks like. So let's go here. So it was a big job. I'm sorry, I have this thing from Zoom sitting in my face. I'm going to move out of my face here. So here's the SMARTool for Russian. I hope you can see it. I hope it's big enough here. Yeah, and anybody can use this. This completely free. You don't need to sign in or anything. The first thing you do here is you choose a level that you might be studying at. Let's say I'm at the A2 level, and then I have various ways that I can search for words here that I'm going to learn. And I can start, for example, by topic. So I guess we all like food, right? So we can start with this word. For all these, I can show a translation. This is the word appetite. So you see that appetite is in all of these examples. Russian has mobile stress, and there's been research that has shown that putting in stress marks, learners just ignore them. So the best way for them to actually learn it is by hearing it. And I have this set up so that this is a voice synthesizer, they can listen to it.
Пойдем в лес, заодно аппетитно гуляем.
I'm going to say the intonation might not be completely perfect because it is synthesized, but the stress on which syllable they need to put the stress on is almost 100%. It's extremely, extremely good. And they can also choose, you know, gender appropriate.
Пойдем в лес, заодно аппетитно гуляем.
So they can do all these, and then you can toggle through. And apparently bulichka, you see this is only used in the nominative plural practically. These are pastries. Then we have, you know, sandwiches and such, and a bottle. So we have various words. Here's a verb to boil, to cook. My favorite part of this is actually search by analysis. Let's go to another level just to be more fun. So search by analysis, here I can search by various combinations of the grammatical categories that are relevant. So for example, if I'm teaching the dative plural, here dative plural is actually the rarest form in Russian, but here I can find words that actually do occur in the dative plural. Or if I'm teaching, you know, some things that are actually fairly hard to teach are, like, for example, imperative forms. So for example, so if I want, let's do a perfective imperative. So I could do a perfective imperative. Here's something that happens often in a perfective imperative, or this one. Or I can also do gerunds, perfective gerunds. I should do this maybe with, I can do this all levels so I get more of them. So then I can find, even for forms that are pretty rare, I can find some words for which those particular forms are very, very common. And so then we can learn those difficult, I mean, these things like participles and gerunds are really hard to learn, but I can learn those based on real words that really occur in those forms. I can also search by dictionary, and I can also, if I'm Russian, I can just type in a word. So stoyat for stoyat. So I can just jump to any form. I also, all of those abbreviations are explained here, and we have something about the project and also where all of the source code is and the article that it's based on. So yeah, so that's the SMART tool. But I also told you that we can customize it. So here I have all of these levels, A1 through B2. But we have now launched this semester. We have the first group of Norwegian students as guinea pigs learning from an edX course that we've created. It's basically a MOOC called Min russiska reise, which means my Russian journey. And what we've done here is this is sourced from all the same data, but basically we've broken down all of the A1 level vocabulary into lessons, and they can just choose a lesson. So if we take this lesson, then I can go into dictionary, and here are all the words that I learn in this lesson. And, you know, I can, you know, learn how to use this word, and etc. So and this was fairly straightforward to do because we have all of the same data. It's sourced in all of the same way. So this is just an example of how we can use this in the classroom. I wanted also just quickly to show you the constructicon, since I've sort of mentioned that. Maybe I can make this slightly bigger so you can see it. No, oops, sorry, that's because I'm in Russian here. Wait a second. There we go. Yeah, so this is also a free and open resource, and here we have over 2,200 constructions of Russian. And I don't know, I'll just bring up something, an example here. You can search them. You can search them by typing in anything here, but typing in strings that are in this top line here. But here, this is basically this is a construction that, and here's this is meaning, and literally it means without 5 minutes a doctor. But basically it means that we have somebody who's about to make a major career change, going up, going up on the ladder. And here we have this construction. So this would be, you know, a way to use the word doctor, also a way to use all of these other words. So this is, you can see how these two projects sort of work together with each other. And here we have corpus examples again. We have a CEFR level, and then we have additional information with common fillers. So it can be a doctor, an engineer, a lawyer, a professor, blah, blah, blah. And then we have lots and lots more information. And it's also, you can get a daily dose. So you can, if you're learning Russian, you say, I'm at the A1 level, I want to get 5 random records of constructions that I should learn at this level. So I can toggle through these here. And there's also advanced search for all kinds of things. Everything that's in the everything that these things have been tagged for, one can look through it. So this also interacts with the SMARTool, because we have to keep track of all of these typical grammatical constructions. So let me go back to I think I'm almost done here. I think I've talked probably more than enough. I think I only have like maybe, do I have any more slides? Maybe down here. Yeah, no, I think I'm actually done here. So so I'm going to stop sharing and say thank you very much to everybody who was patient enough to listen, and I'm ready to take questions.